Okay, so most of the time in these lectures, I will be not sort of repeating what's in the textbook, but rather building on it in some way or taking it another direction. However, there are times, and this is one of them, when I will kind of follow the textbook because, if I think something is sort of new to you, perhaps like correlations are, and, it involves a little bit of math and stuff like that, and some sort of new ideas, then I may actually give my own lecture that kind of follows what the textbook is doing, but say it, of course, in a different way and give you a different examples that I hope will make the concept clear, just so that I'm sure that you have a good understanding of what it is. And as we're kind of talking about working our way towards experiments and the scientific method, I think these things are very important to your sort of career as a psychologist, but often also in your real life. So let's kind of start there. What I mean by that, I'm going to show you this in a moment, but is in life you are constantly bombarded with scientific facts. Scientific facts. You'll see things like this. Drinking coffee may help you live longer. We're going to play this story in just a moment. I'll just let you kind of think about it. But a lot of times these facts are actually correlations that they're telling you about. And what we hope you kind of get from this chapter is a stronger ability to consume knowledge is kind of how we say it, so that you can watch an ad like this and really think about the data that they're presenting to you, and whether you think it actually says what they claim it says or not. Because very often media just stick a real oversimplified kind of heading on something, and you have to actually be able to think a little deeper and understand what you're looking at in order to evaluate it. And again, often it's correlations that are involved. So I'm going to use this as a context. So let's start with this story.
I look to be here for a long time, and so that's perfect.
Researchers followed nearly 200,000 people over 16 years and found drinking coffee was linked to reduced risk of dying from heart disease, cancer, stroke, diabetes, respiratory, and kidney disease.
Let me just punctuate this. What was the critical word he just said? Linked. Let's actually hear that again.
Risk of dying from heart disease, cancer, stroke people over 16 years and found drinking coffee was linked to reduced risk of dying from heart disease, cancer, stroke, diabetes, respiratory, and kidney disease.
So linked. What do they mean by linked to it?
How much? Just 1 cup a day lowered the chance by 12%. Bump that to 3 cups a day and the risk drops by 18%. And it didn't matter if coffee was regular or decaf.
They contain a lot of antioxidants, so those are probably the compounds that might have health benefits.
I think it's great as I drink up.
From con leche to cappuccino, researchers said the benefits of coffee seem to be the same for men and women from many ethnic backgrounds.
Coffee consumption can be incorporated into a healthy diet and lifestyle, and really there's no long-term harm.
Hey, NBC News fans,
All right, so let's get out of here and go back here. All right, so there we have a story. So, the first thing to think about, I'm going to come back to the story when we talk about experiments, because the first thing I kind of think about when I look at that is, hang on, was this a real experiment? And they don't really tell you, but what do I mean by a real experiment? Well, a real experiment manipulates a variable across some groups. So was it the case that, do you think, was it the case that they got a bunch of people and they said for the rest, for the rest of your life, basically, I don't want you to drink any coffee. And you guys, I want you to drink 1 cup a day. And you guys, I want you to drink 2 cups a day. And then these people lived their lives, and some of them eventually died of heart disease and all those things you see. And if that was the case, and if people who didn't drink the coffee got those diseases way more than those who did, wow, then we'd say, okay, it's the coffee that's going on. But do we think that's what really happened here? Probably not. Probably they just asked a bunch of people, how much coffee do you drink? Or, more likely, they waited till they looked at medical records or somehow and connected the amount of coffee a given person drank with the likelihood of them dying of some disease. Linked. Remember that word, linked? So what they're probably showing is an association. People who drank more coffee were less likely to die of these diseases. Okay, a correlation. So we'll talk about that. There is one thing I want to kind of just put in your head every time you hear one of these medical stories. You know, a good way for something to reduce your risk of dying of cancer or heart disease or whatever, let something else kill them first. So maybe, coffee causes everybody to die of, I don't know, driving their car into a transport or something because they're so agitated. Well, if it did, then it would lower the risk of them dying of other things, right? So first of all, it's even, I'd like to see the study. So all of this to say, when you see these ads, you should be filled with doubt. Critical thinking should start to take over. You certainly should not just say, oh, look, coffee's great for you. You should say, I'd like to know a little bit more. Maybe I actually want to see that study, what they did and didn't do, and understand where this data came from. Okay, and so let's kind of go through that in a number of situations, but focusing on correlations and talking about what they do tell you and what they don't tell you. And that's really the important thing. So in that grand scheme of things, I actually want to think of where correlations fit in this greater picture that we've talked about, because we began with naturalistic observation. And I said naturalistic observation can sometimes bring forward questions. You can start to see things. So you can start to see, for example, relationships. So let me bring you back to Jane Goodall. And I said when she was out there, she noticed that it seemed as though this eye contact thing, that a certain person, depending on their social rank, would defer to some other apes and would look at other apes. So there was an association, she thought, between one's rank in the group and the number of other individuals, let's say, that they would defer to. Okay, she saw this sort of relationship. It looked like there's something connecting these two things, rank and this greeting kind of behavior. And that's what starts to make you think, oh, but is there a real relationship? Are those things related or not? That's what we're going to talk about with correlation. And it will be that specific. Are they related or not? And then we can start to get at, if they are related, is one causing the other? Is your deferring behavior causing you to have a certain social rank, or is your social rank causing you to defer or not? And so now we can start really getting at why or what's the character of the relationship. Okay, and that's where experiments are going to take us. But right now, let's just focus on this idea of trying to see if two things are related and some of the thorny stuff that happens with that. So, first of all, what's the context we're talking about here? What we often would do is find a given individual, and we would ask them at least two questions. We would want 2 bits of data from them. Remember that subjective objective. So it doesn't have to be subjective, but it might have been in this case, right? As we connect with that, the coffee case, people might have been just asked, how many cups of coffee do you have a day? This is a great example for the subjective thing, because there are some people in society, I'm generally one of them, who are very habitual in their coffee drinking behavior. They can tell you exactly how many coffees they have on an average day because they do the same thing every day. But there's other people who fluctuate. And so those people who fluctuate, when we now say how many per day, this is the problem with the subjective measure, right? They are not taking their last 50 days and counting the number of coffees and dividing by 50 and giving you a precise objective number. They are going, I'd say about 2. So they're just kind of, it's telling you what they think is about right. And again, which would we prefer? Something we could actually measure, or something where we rely on somebody else to give us the data? Because there's the subjective objective. But let's say we find out how much coffee somebody drinks a day, and then we need to find out whether or not they, ultimately die from one of these conditions. This is starting to feel like a Broca experiment here when you get into death rates. But let's imagine something else. Let's imagine coffee, drinking coffee, and performance on an exam. So let's say we ask students, how much coffee do you tend to drink a day? And we also ask them, how well did you do on your exams? What's your GPA? No, let's actually stick to final exams. What was your average on your final exams? And so the same person gives us two numbers, right? This is my this is my number of coffee per day. This is my number of this is my exam performance. I'm actually going to skip out of here for a second because as I think of this, I should have shown you a scatter plot better. It would be good to and it actually, is there a scatter plot generator? By the way, let me just take this as an opportunity. You will occasionally come across things in the textbook, and you might see a graph like this, which is a scatter plot, and the textbook author's talking about it, and you're looking at it, and you're not really sure what you're looking at. Find out. Type scatter plot in Google. Look around a little bit. Make sure you feel good. Here's a Khan Academy. So this is probably aimed at a sort of high school level. And it really would probably show you what a scatter plot looks like. Let me see if I can put scatter plot generator. They're probably going to try to charge me for things, but let's see if we can do one and it just allows us to do it. Okay, enter XY values. Excellent. So let's say we have individual 1 who drinks 4 cups of coffee a day, and their average on exams was 75. Individual 2 has 2 coffees a day, and their average on their exam was 56. Individual 3 has 5 coffees a day, they're around 72. And I'm just going to create a bunch of these now. Another 5 coffee a day person, I got 90. A 1 coffee a day person, I got 50. A 2 coffee a person a day, they got 65. All right. And a 3 coffee a person a day, they got 80. Let's focus on this last person for a second. 3 coffee that got 80. Okay. So let me submit this data. Let's see what we get. There we go. So what we have here, let me just alert you to this person. Let's take a look at them. So this was an individual who had 3 coffees a day, and they got 80 on average on their exam. So this 1 point, represents the intersection of those 2 values, the 3 and the 80. And similarly, this was another individual. So we had 2 individuals that drink 2 cups of coffee a day. One of them was around 57, I guess, and one of them was around 65 or 66. So first question to you, do you understand what these points are? These, if we look down here, 1, 2, 3, 4, 5, 6, 7 points. 1, 2, 3, 4, 5, 6, 7 points. So each pair ends up being a point on a scatter plot, okay? Let me click on this puppy. Correlation coefficient. 0.82, basically 0.83 is what I got from, here's the formula, by the way. Looks horrible. It's not. It looks horrible. It's not. I'll tell you about it in a moment. But at any rate, and in fact, this tells you how that number came from, by the way. So sometimes, let me just mention this, sometimes textbooks think, oh, students are scared of math. I got to talk about correlation in a way that's very gentle and doesn't scare them. And some of you might be like, I'm not that scared of math. I'd rather actually understand what's going on. Well, this part right here tells you exactly how we went from these numbers to the correlation coefficient. And, while some of these things look really nasty, they're really not when you actually kind of get into this. So this is like this, the total number of value. We won't go into the details of it. Now I'm being the kind, gentle person, right? Let me go back to scatterplot and do the scatterplot back again. I was kind of hoping they would do these on top. I'm going to try the linear regression just to see if it'll do what I hope it does. There it is. Good. So what the linear regression did is it just put what we call the line of best fit on the points. And as you see with this line of best fit, we have one that's going upwards and to the right. And you also probably notice, so this doesn't show us the correlation in the same one. It was 0.85. It doesn't, I'll go back to the correlation. Well, let's go back to the correlation. So here's 0.83 basically, but it's a positive 0.83. So let me flip you back to here then. So when I'll come back to that one. So when you have a correlation, first of all, let's just talk about the direction of the correlation. So you now hopefully feel a little more comfortable about these. This is a scatter plot of points. In fact, this one looks quite a bit like the one we just had to some extent. This is a positive correlation. What that means is that as one of our variables gets larger, number of coffee drank, the other one also gets larger, average grade. So we're seeing here that people who drank more coffee report a higher average grade. There seems to be a relationship with that. The more coffee, the higher your grade. The less coffee, the lower your grade. Okay, that's what we call positive correlation, meaning that the two move in the same direction, number of coffee and grade, versus a negative correlation. So it might just as easily have been that the more coffee you drink, the worse you do on your exam. So if this was exam score and this is number of coffee drank, then the more coffee people drink, the lower their exam score. That would be a negative correlation. Okay. Now it might also be the case that when you plot these things, you don't see a nice little pattern that goes up or down. You just see a cloud of dots. And that suggests no relationship at all. So, yep, some people drank more coffee than others. Some people did better on the exam than others. But we don't see any direct connection between those two variables. The amount of coffee drank does not seem to predict the performance on the exam. Okay, so get your head around that first. Positive or negative correlation. Let's hit that a little harder with a favorite example of mine a little bit. And heck, while we're here, let me just teach you a mnemonic strategy that you might like to learn. When we talk about any plot like this, we talk about the x-axis and the y-axis, which we also sometimes refer to as the ordinate and the abscissa. Do you know which one's the ordinate and which one's the abscissa? X or Y? I will tell you a way now and you will never forget it for the rest of your life. Are you ready? I'll do it to the face. I'll do it here. Look at my face. Ordinate, abscissa. Ordinate, abscissa. I'm exaggerating, but no, look at my mouth. Ordinate, abscissa. The ordinate is the y-axis. Ordinate goes up and down. Abscissa is the x-axis. You'll never forget that again. You're welcome. Okay. So now that we have that straight, ordinates and abscissas, scatter plots, we get the direction of the correlation. Just to kind of think this through in your head, let's do this example, but I want you to think about it at two levels. So let's start by saying we're talking to a bunch of kids, but we pick a very specific age of kid. We pick that age when the girls have gone through puberty, but the boys have not yet. Okay, so girls typically hit puberty before boys do. And at that time, they shoot up and grow and go through all the physical changes, and boys are still, so the girls are becoming women and boys are still boys, so to speak. So let's say at that point, we ask the girls in a given class, how tall are you right now? And how attractive do you think you are on a 10-point scale? So we call this perceived self-attractiveness. So how attractive do you think you are? What do you think would be the relationship between these two things at that point in their life? Do you think the taller girls feel more attractive than the shorter ones, or less attractive than the shorter ones? I would suggest at that age, we might see a negative correlation. The taller the girl is, the less attractive she feels at that age. So the taller, as height goes up, attractiveness goes down. The perception of attractiveness. Now, this isn't really whether she's attractive or not, of course. What we're really sensing here is she's maybe feeling like a little bit out of place because she's so much taller than all these little boys, and so she might feel a little like a monster looming over the little boys, so to speak. And at that point, it might not feel very attractive to be tall. If we wait until she's, say, 20, and now we ask a bunch of 20-year-old women their height and their perceived self-attractiveness, we might find that that negative correlation that used to exist when they were young becomes a positive one. It might be at that age, the taller you are, the more attractive you feel. Because a lot of the boys are now taller than most of the girls. And so by being tall as a girl, you are closer to a lot of the boys in that sense. So all this to say, given two variables, height and perceived self-attractiveness, the kind of relationship they show might be negative in some situations and positive in others. And so when you get exposed to a correlation, really think about what is it they're saying. So if we go back to that coffee one, they're saying the more coffee somebody drank, the less likely they were to die of heart disease, etc., etc. So they're reporting a bunch of negative correlations between coffee drinking and certain ways of dying. Okay. There is the direction of the correlation. That's what we've been talking about a lot. And then there is the magnitude. How strong is the correlation? These two things are relatively, they're talking about completely different things, okay? The magnitude is the strength, and the sign of it is the direction. So we will talk about a correlation being something like, well, in this case here, it was 0.82, positive 0.82. This number that we're going to get, this R value, always ranges between 0 and 1, we could say, but it can be a positive or a negative. So you almost want to think of those two things different. There's the magnitude that goes from 0 to 1, and then it's preceded by a sign, a positive or negative. But that sign is just telling you whether the relationship is positive or negative. And the value is telling you how strong it is. Okay, and the closer that value is to 1, the stronger the relationship is. And so when we see a 0.83, that's a strong relationship. So, by the way, is a negative 0.83. In fact, it's just as strong. It's just the other direction, right? So a positive 0.83 or a negative 0.83, those are equally strong correlations. They're just suggesting a different relationship between the variables. And these correlations always go from 0 to 1. Okay. So you'll get more of that in your textbook, but just to kind of make sure you've got those sort of ground rules down. All right, so correlations, I mean, that's what they ultimately do tell you, right? You can pick any two variables and it will tell you, is there a relationship? And if so, is it positive or negative? And how strong is it? And that's cool. And so you now know, if we go back to the coffee and the exam stuff, and let's say we take our data, we now know that there's something about people who drink a lot of coffee in the sense that they do better on their exam as well. Somehow those two are connected. The correlation does not tell you how. And there's a number of ways they can be connected. But you get tempted. Correlations tempt you into certain ways of thinking. Here's a correlation to think about a little bit, and let's just talk about it. We've got a bunch of countries. Instead of people, we've got a bunch of countries. And for each country, let's say Czechoslovakia, we measured two things about them. We measured their average animal fat intake. How much meat do they eat? But not just how much meat, but what kinds of meat? What percent of fat do they actually get per day from animal sources? And what is their age-adjusted death rate? Okay? And what we see here is a positive correlation, right? These countries over here, New Zealand, Denmark, even UK, Netherlands, there we are, Canada, have a lot of fat intake, a lot of animal fat coming in, and they die a lot. Versus if we go way to the extreme over here, places like Japan, Thailand, El Salvador, a whole lot, much more vegetarian diet, a whole lot less fat intake. And a lower rate of death overall. And so when you see this kind of laid out like this, there is a strong temptation to say, eating animal fat kills you. Now, as soon as you say that, you've crossed a line. you are now giving what's called a causal, you are producing what's called a causal statement. You are suggesting that this is causing this to be high. So when you have this, it causes that to be high. And when you see data like this, that's your natural temptation to think, oh, well, that's how that data makes sense. But the problem is there's other ways a relationship, or sorry, a correlation like this can happen. Let me give you a crazy example. It is a crazy example. Can I do this? No, I can't. I was trying to make up something really crazy. This is for females, by the way, just for females, for whatever reason. One of the reasons we get tempted to make these causal explanations is in some cases it just seems like that's the only way to interpret it. And this is the other tricky thing about correlations. I've been trying to kind of come up with an alternate story of this one. But once we see a certain story, we just think that's the way to interpret the data. And it becomes really hard to see that the data can actually be interpreted in different ways. And especially when we get into what we call third variables. So let's hang on for third variables and just point for here to this temptation of causation. You want to say, oh, we now understand things. But let me use this data set because it'll help a little bit more to show that things can run a couple of different ways. So let's do this one. A correlation between students' grade and teachers' ratings. So what we actually imagine, we have 4 different topics here, but what we actually imagine is students take a course, they rate the teacher at some point. How good is this teacher? They give a rating. And we also know their grade. What relationship do you expect with those? Well, what we're seeing is a positive relationship. Big time. We're going to talk about all these little, I'll get you to these little points in just a second about the probabilities. We'll have a separate talk on that. So let's not worry about those for now. But what we see is a positive, these are all positive correlations. What does that mean? Well, that means the ones that had the higher grades gave the higher ratings to the teacher. So as grades went up, so did the teacher ratings. They're moving in the same direction. So it's a positive relationship. And we see the strongest in math, but we're also seeing it in the reading and the science and the technology. Okay. What does that mean? Causally. Well, is it the case that those people who really understood the teacher and connected with the teacher, and so they gave a high rating because they really liked this teacher, and they're also really learning really well from that teacher, and so that's why their grade is high. It's a really for them. So let me say it this other way: a given teacher might be perceived as a really great teacher by some students and not so great by others. That'll come through in the ratings, right? But maybe the people that perceive a teacher as great do so because they're learning a lot from them. That teacher's working for them. And so because they're learning a lot, they're also getting good grades. So it's the greatness of the teacher that's producing the good grades for those students. And so the teacher is causing the increase in grades. Maybe. Another story, students are happier when their grades are good. And so when they're in a class and they're getting a good grade, if they're now asked to rate the teacher, they think a teacher's great if they're getting a good grade. So it's the grade that's causing their perception of the teacher. Okay, so this just to show that causally it could be one or the other. We don't know. All we know is these two things are related in a positive way. One could cause the other to be higher, vice versa, or even, there could be a lurking third variable somewhere in the distance that's actually creating the relationship we're seeing. So let me tell you this story. I like this story because you guys don't know this, by the way, probably. One of the many ravages of COVID is that you guys don't know I'm tall anymore. I'm just this head now to you guys, but I am actually tall. I'm 6'3". That's one of the first reactions most students have when they actually see me in person is, my goodness, sir, I didn't know you were that tall. So I'm 6'3", and I've always liked this little data point that says each extra inch correlates with an estimated $800 in increased annual earnings. When you look at, let's see if we can find this. Always fun to do this, by the way. The internet's a great source of scatter plot, height, salary. So if we look at how much people make, and I highly encourage you to do this kind of studying. See if we can get a nice, there it is. Doesn't look all that impressive. There you see men and women kind of laid out. Quite a messy kind of scatter plot. So one of the things, just to show you the correlation value here, is remember the other one was 0.8, and we're seeing a nice line. This is 0.137. Remember I said the closer it is to 1, the stronger the relationship is. This is pretty close to 0, but it's still significant. Again, we'll get into the significance idea here. But the notion is that we do see a relationship going on here. The taller you are, the higher your salary becomes. Okay? What the heck? What does that mean? Why would that be the case? Is it that when they're deciding salaries and raises to give somebody, somehow those tall people just seem like they're more deserving, and so we're rewarding tall people just for being tall? That doesn't sound very fair, does it? People have dug into this to try to figure out what's going on, and here's what the story seems to be. If you come from a relatively wealthy family, if your socioeconomic status is pretty high, as we call it, then your family seems to be, so first of all, you probably had really good nutrition when you were young, because your family had, the means to feed you good meals every day, and that allows you to reach your physical potential. In terms of height, then it allows you to reach your maximum possible height. So socioeconomic status, the same people born with the same genetic potential for height, some will reach it if they get all the food they need, others won't if they don't. And so maybe the reason some people are tall is because they had exposure to more nutrition, and that's pretty common if you have a high level of socioeconomic status. So socioeconomic status can cause you to be taller. It can also mean if you grew up in a relatively rich family, your parents are probably networked with other people who are in the work industry and who maybe have jobs that you might have a shot at. They are better connected, better networked. They often say it's who you know, right? And the idea would be if you're the kid in a rich family, there are more people that you might know in that sense. And so maybe being of high economic status, A, makes you more likely to be tall, and B, makes you more likely to stumble into a great job because your mom or dad knows somebody. And that was your in, okay? So it's the socioeconomic status that's causing you to be both tall and get the good job. And therefore, it looks like height and a good job are connected, but they're connected through a third variable that's causing both of those things to go up or down together, okay? Whew. That's complicated, right? The real punchline, to get from all this is just don't get seduced by a correlation. When you see a correlation that suggests a relationship between things, don't assume causality. Just say, okay, that's interesting that they're related. But then ask to see an experiment, because an experiment is the thing that will actually tell you if that causal relationship is there or not. Okay. That'll be it for this segment. I'll see you in the next one.